In this video, we are going to see integration of cotangent x. Okay, in trigonometry, we all know the formula for cotangent x. That is, cotangent x is equal to cosine x over sine x. Since cotangent x is equal to cosine x over sine x, in the given integration, we can substitute cosine x over sine x for cotangent x. Then integration of cotangent x dx is equal to cosine x over sine x times dx. Okay, here in this integration, the denominator is sin x. So the derivative of this sin x is cosine x that we have in numerator. Okay, in any integration, in the function, the derivative of a part of the function is somewhere else in the same function. We can use the method of substitution. Here, we have the derivative of sin x in numerator, that is cosine x. Since the derivative of sin x is in the same function, so we can use method of substitution in this integration. For that, we have to substitute a new variable y for sin x. Here you may have a question, why I substitute the new variable y for this sin x? The reason is the derivative of this sin x is at numerator. That is the reason I'm substituting y for sin x. So for whichever part we have the derivative, for that part we have to substitute the new variable y. So now I'm going to change this complete integration to the new variable y. For that, I need to find the derivative of this equation with respect to x. When I find derivative of y with respect to x, I'll be getting dy over dx. When I find derivative of sin x, it will be cosine x. If I multiply both sides of this equation by dx, then I get dy is equal to cosine x times dx. Okay, now we can substitute y for sin x and dy for cosine x dx. So then we get the integration for this cosine x times dx, we can substitute dy, and for this sin x, we can substitute y. So integral dy over y. Okay, this integral dy over y can be written as 1 over y times dy. Okay, we know that derivative of log x, that is ln x, is equal to 1 over x. So integration is the reverse process of derivative. So the derivative of log x, that is ln x, is equal to 1 over x. If you find integration of 1 over x, that is equal to log x. So in the same way we can approach this, the integration of 1 over y with respect to y is ln y plus c, integral constant c, because it's an indefinite integral. Okay, so now we got the answer in the new variable y. We should not give the answer in the new variable y because the variable y was taken by us. It has to be replaced by the original stuff. We know that y is equal to sin x, so y has to be replaced by the original stuff, sin x. So ln sin x, I substitute sin x for this y plus c. So finally, integration of cotangent x is equal to ln sin x positive c. In calculus, we use only natural logarithm. That is why I'm using the spelling ln. Ln stands for natural logarithm. And logarithm is never defined for negative values. So this sin x can now be a negative value. So to make sure that I use absolute value for this sin x, positive c. So integration of cotangent x dx is equal to natural logarithm of absolute value of sin x, positive c. I think this video is much helpful for the students who study calculus. If you like this video, please subscribe our channel. Thank you all.